Welcome back, students. Today is Q&A session 13 from the chapter of units and measurement, and today I have taken one question which pertains to the calculation of zero error and the zero correction. So before solving this question, we will first of all discuss about the zero error and the zero correction in brief. So here I have made one small diagram depicting the vernier caliper. So the vernier caliper has got a main scale and it has got a vernier scale. So if the zero of the main scale is coinciding with the zero of the vernier scale when the jaws are brought in contact with each other, then in that case there is no zero error. However, if the zero of the this vernier scale is on the right side of the zero of the main scale, as I have shown it here, then in this case the zero error is positive. Here the zero error is positive. Zero error is positive when the zero of the vernier scale is on the right side of the zero of the main scale when both the jaws, that is the jaw of this main scale and the jaw of the vernier scale, are brought in contact with each other. So in this case the zero error is positive, and in this case we will apply negative zero correction, and zero correction is equal to least count into the coinciding vernier scale division. Now what is zero correction? So in order to understand it, I will be writing here one formula, that is the measured value in case of a vernier caliper. Measured value in case when we are taking the measurement with the help of vernier caliper is equal to main scale leading plus vernier scale leading into least count plus minus zero correction. Now when the zero error is positive, as it is seen here, in this case the zero of the vernier scale is on the right side of the zero of the main scale, so the zero error in this case is positive and we will apply negative zero correction. So what we will do is the meaning of this negative zero correction means is that in this measured value the zero correction will be taken as minus. That is, the value of this zero correction will be subtracted from the value of this main scale reading plus vernier scale reading into least count. This is the value which I am getting from the this vernier caliper. This is the measured value with the this is the measured value of any dimension with the help of a vernier caliper. So this is equal to main scale reading plus vernier scale reading into least count. But if there is a zero error, then what we apply the zero correction. In the case of a positive zero error, negative correction, negative zero correction is applied. That is, what we do is we subtract this value, the value of the zero correction, from the measured value. So the true value will be equal to MSR plus vernier scale reading into least count minus Z correction, zero correction in case of positive zero error. So the true value of any physical dimension which we are measuring with the help of a vernier caliper will be equal to main scale reading plus vernier scale reading into least count minus zero correction in case of a positive zero error. And now there is one more case, that is if the Vernier, if the zero of the Vernier scale is on the left side of the main zero of the main scale, that is, if this zero, that is the zero of the Vernier scale, is on the left side of the zero of this main scale, इस zero के left side में अगर Vernier scale का zero है, in that case the zero error is negative, and we will apply the positive zero correction. That is, in that case the true value will be equal to main scale reading plus Vernier scale reading. Okay, that is the coinciding Vernier scale reading plus zero correction. So this is the true value in the case of a negative zero error. Negative zero error happens, or negative zero error can be seen when the Vernier scale, when the zero of the Vernier scale is on the left side of the zero of the main scale, when both the jaws are in contact with each other. So in that case, the zero error is negative and we apply the positive zero correction. So this is a very this is what I wanted to just discuss here before solving this question. And now we will solve this question. Now this is the question which is means very similar questions has been asked in the I think IIT JEE examination. So I have taken a very similar question so that you can understand how to calculate first of all the zero correction, and you should also know when the zero error is positive and when the zero is negative. And if you are able to understand both these two concepts, then it will be very easy for you to solve these types of questions. Now here, the least count of the main scale of a vernier caliper is 1 mm. That is, the least count of the main scale of the vernier caliper is 1 mm. It means that the value of one main scale division is equal to 1 mm. And the vernier scale is divided into 10 divisions and coincides with 9 divisions of main scale. So it means that 10 divisions of vernier scale is equal to 9 main scale division. So it implies that one vernier scale division is equal to 9 by 10 main scale division. Okay? So which is equal to 0.9 main scale division. Now the least count of the vernier caliper is given by 1 main scale division minus 1 vernier scale division. This is the formula for calculating the least count of a vernier caliper. So 1 main scale division is equal to 1 mm minus 1 vernier scale division is equal to 0.9 of main scale division. So this is equal to 0.9 into 1, that is equal to 0.9 mm. So the least count is equal to 0.1 mm, or we can also write it in centimeter, that is equal to 0.1 centimeter. Okay. Now let's come to the next part of this question, that is 7th division of the vernier scale coincides with the main scale division when the jaws are touch each other and the zero of the vernier scale lies to the right side of the zero of the main scale. The zero of the vernier scale is lying on the right side of the zero of the main scale. It means that the zero error is positive. Zero error is positive. And we will be applying the negative zero correction. 7th division of vernier scale is coinciding with the main scale division when the jaws touch each other and the zero of the vernier scale lies to the right side of the zero of the main scale. Since the zero of the vernier scale is lying on the right side of the zero of the main scale, when the jaws are brought in contact with each other, therefore the zero is positive and we will apply the negative zero correction. So now zero correction is equal to least count into the coinciding vernier scale division. So here the 7th division of vernier scale is coinciding with the main scale division. So this is equal to into 7. So this will be equal to, zero correction will be equal to least count, because see here in the third part of this question you will write, when this vernier is used to measure the diameter of a cylinder, the zero of the vernier scale lies between 3.1 centimeter and 3.2 centimeter. Okay, so we have to find the measurement in terms of centimeter. So what I have done is I have calculated the least count in centimeter, and similarly the zero error, the zero correction will also be will be calculated in centimeter, which is equal to 0.01 into 7, which is equal to 0.07 centimeter. So the true value, the true measured value will be equal to main scale reading plus vernier scale reading into least count, and since zero error is positive, we will be going for negative zero correction. Okay. So now here I will be just solving this question here. So the true value will be equal to main. Now main scale reading is what? Here it is written the zero of the vernier, when the vernier is used to measure the diameter of a cylinder, the zero of the vernier scale lies between 3.1 and 3.2 centimeter. तो इसका मतलब ये हो गया कि जो मेन स्केल रीडिंग की वैल्यू है वो हो गई आपकी 3.1 सेंटीमीटर. So here I will be writing the value of main scale reading as equal to 3.1 centimeter plus the coinciding vernier scale reading, that is equal to what? The fourth vernier scale division is coinciding with a main scale division. So it will be equal to 4 into least count was equal to 0.01 centimeter and minus zero correction, and the zero correction was equal to 0.07 centimeter. So in this case the answer will be the true value, or you can say the correct diameter of the cylinder will be equal to, you can say that the correct diameter of the cylinder is equal to 3.1 plus 0.04 centimeter minus 0.07 centimeter. So this is equal to centimeter, it is in centimeter, this is equal to so the answer is 3.1 plus 0.04 minus 0.07, 3.07 centimeter. ठीक है. So the correct answer is, that is the correct diameter of the cylinder will be equal to 3.07 centimeter. So our option B is correct. The option B is correct here. So in this question, the most important thing which you have to understand is that the zero error is positive when the zero of the vernier scale is on the right side of the zero of the main scale when the two jaws are in contact with each other, and similarly the zero error is negative when the zero of the vernier scale is on the left side of the zero of the main scale when both the jaws are in contact with each other, and when the zero error is positive we apply negative zero correction, and when the zero error is negative we apply the positive zero correction. So in this way we can find the true value of any physical dimension when there is a zero error in the vernier caliper. If there is no zero error, that is if the zero of the main scale is coinciding with the zero of the vernier scale when the jaws are brought in contact with each other, then the zero correction is not there. Okay, now because in that case there is no zero error. So this is how this question needs to be solved, and the correct option is B, that is the correct diameter of the cylinder is equal to 3.0 centimeter. So thank you very much for joining this session, and in the next session I will be taking up a couple of questions on the same topic, and so till then, have a nice day. Bye.